Heavy machinery has always been at the heart of industrial progress. Wherever iron is shaped, cut, pressed, drilled, or assembled, machines play a vital role in turning raw metal into useful structures and powerful components. When heavy machinery meets iron engineering, strength, precision, and human expertise come together to create the backbone of modern industry. This process is not just about metal and machines. It is about control, planning, and the intelligent use of mechanical power. Iron engineering begins with raw material. Large blocks, sheets, and rods of iron arrive at industrial workshops and factories in their basic form. At this stage, iron is strong but unrefined. It cannot serve any purpose until it is shaped with accuracy. Heavy machinery steps in here, using mechanical force and controlled motion to transform iron into usable parts. Massive machines are designed to handle extreme loads that human hands cannot manage. These machines do not just move iron, they discipline it. One of the most important machines in iron engineering is the lathe machine. As iron components rotate at controlled speeds, cutting tools remove excess material layer by layer. The process may look simple, but it requires deep engineering knowledge. Speed, pressure, and tool angle must be perfectly balanced. A slight mistake can ruin an entire component. Heavy lathes are built with rigid frames to absorb vibrations and maintain stability while working on iron parts that may weigh hundreds of kilograms. Milling machines play a similar role, but in a different way. Instead of rotating the iron, these machines rotate the cutting tool. Heavy, duty milling machines carve slots, grooves, and complex shapes into iron blocks. These shapes are essential for gears, machine housings, and structural supports. Every cut is planned according to engineering drawings. Precision is everything, because even a small error can cause failure when the machine is used under heavy load. Press machines are another powerful example of heavy machinery in iron engineering. Hydraulic and mechanical presses apply enormous force to iron sheets and components. This force can bend, shape, or compress iron into desired forms. Presses are used to create frames, panels, brackets, and industrial parts that must be strong and uniform. The power involved is extreme, yet it is carefully controlled. Engineering calculations decide how much pressure is applied, how long it lasts, and how the iron will respond. Welding is another critical stage where machinery and iron engineering meet. Heavy welding machines join iron parts together using heat and electrical energy. Welding is not just about melting metal. It is about creating bonds that are as strong as the original iron. Industrial welding machines allow engineers to control temperature, current, and welding speed. This ensures that joints do not crack under stress. In heavy machinery manufacturing, welding quality can determine the life or failure of an entire system. CNC machines have transformed iron engineering by introducing automation and digital control. CNC stands for computer numerical control. These machines follow programmed instructions to cut and shape iron with extreme accuracy. Heavy CNC machines can operate continuously for hours, producing identical parts with perfect consistency. This level of precision is essential for engines, gear systems, and industrial equipment where parts must fit together flawlessly. Despite automation, human skill remains essential. Engineers and machine operators must understand both the machine and the behavior of iron. Iron reacts differently to heat, pressure, and cutting forces. Experienced workers listen to the sound of the machine, feel vibrations, and observe surface finishes to judge whether the process is correct. Heavy machinery may provide power, but human judgment provides intelligence. Maintenance is another important aspect of heavy machinery in iron engineering. Machines that work on iron face constant stress. Bearings, gears, and cutting tools wear out over time. Regular inspection and maintenance ensure that machines operate safely and efficiently. A poorly maintained machine can damage iron parts or cause serious accidents. Engineering discipline is required not only in production, but also in care and upkeep. Safety plays a major role in environments where heavy machinery and iron engineering coexist. Iron parts are heavy, sharp, and unforgiving. Machines generate heat, pressure, and motion that can be dangerous if not handled properly. Safety guards, emergency stop systems, and protective equipment are essential. Engineers design machines with safety in mind, and workers follow strict procedures to prevent accidents. In this way, safety becomes part of engineering culture. Heavy machinery is also responsible for shaping iron on a large scale. In construction and infrastructure projects, machines cut and shape massive iron beams and columns. These components form bridges, buildings, and industrial plants. Without heavy machinery, such large-scale iron engineering would be impossible. Cranes, presses, and cutting machines work together to handle iron structures that weigh tons. The relationship between heavy machinery and iron engineering is built on efficiency. Machines reduce time, effort, and material waste. They allow engineers to achieve results that are consistent and repeatable. In modern industry, efficiency is not a luxury, it is a necessity. Heavy machinery ensures that iron engineering meets deadlines, quality standards, and economic demands. Technology continues to improve this relationship. Modern machines are equipped with sensors, monitoring systems, and digital interfaces. These tools provide real-time data about temperature, pressure, and tool condition. Engineers can analyze this data to improve performance and reduce errors. Smart machinery represents the future of iron engineering, where machines not only work but also communicate and adapt. Environmental considerations are also becoming important in iron engineering. Heavy machinery consumes energy and produces waste. Engineers now focus on optimizing machine performance to reduce energy use and material loss. Efficient cutting methods, recycling of iron scraps, and improved machine design all contribute to more sustainable engineering practices. At its core, iron engineering is about problem solving. Engineers must decide how to shape iron in the most effective way. Heavy machinery provides the means to implement these solutions. Whether it is creating a small precision part or a massive structural component, the process follows the same principles: strength, accuracy, and reliability. When heavy machinery meets iron engineering, the result is more than just metal parts. It is the creation of systems that power industries, support cities, and drive progress. Every machine, every cut, and every weld represents human innovation combined with mechanical power. This partnership has shaped the modern world and will continue to do so in the future. Iron may be strong by nature, but it is heavy machinery that unlocks its full potential. Through engineering knowledge, careful planning, and skilled operation, iron is transformed from raw material into the foundation of machines, structures, and technology. This is the true power of heavy machinery meeting iron engineering.